Right, grade 7. So this week we're moving on to Unit 9, Insulation and Energy Saving. It is a pretty straightforward unit. There's just a few things that you have to take note of. So we have touched on insulators already. We spoke about it when we went through heat transfer. And we said that insulators are there to prevent the flow of either heat or electricity, and is to protect us from getting burnt or from electrocuted. So in this unit, we're just going to talk about, and it says here that you'll learn about using insulating materials to reduce heat loss by conduction, convection, and radiation, as well as good designs that improve the conservation of heat energy. So remember, we want things to be as efficient as possible. So therefore, scientists are always going to look for the ways to preserve energy, because it's either going to be transferred into something else and lost into something else. So we are going to have heat losses as well as heat gains. So if you look on page 124, it says that heat energy is lost to the environment by conduction, convection, and radiation. So for example, our bodies lose heat all the time by radiation because we radiate the heat off of us. It says hot water geysers lose heat by radiation. It says heat is lost by convection when we cook food over a fire. And a hot tea or coffee also loses heat by conduction through the cup it's in. The hot tea or coffee also loses heat by convection as well, because you can feel that it is quite hot if you hold your hand above the cup. But they're just referring to, in this case, if the cup was cold and you throw hot water in, the hot water is going to start to conduct into the cup, and therefore it will heat the cup up as well. Okay, so it says heat energy can also be gained or absorbed from the environment by conduction, convection, and radiation. For example, solar water heaters absorb heat from the sun by radiation. Convection currents from the heater warm up the air in the room, and food in a pot on the stove gains heat by conduction as the pot is busy touching the stove. Remember, with conduction it needs to be touching. Convection is when it's traveling through a small space of air or liquid, and then solar would be radiation. Okay, so solar water heaters. So this is what we're going to focus on mainly today, is a solar water heater and how it works. There's also an animation that's been put in the video description for you in the schedule. So please watch that animation. You'll see how the solar panels with the school's pool works, and that's what we're going to explain now. It is totally different now from the solar panels with the photovoltaic cells that generate electricity. So we're going to get into, because you've already learned about the photovoltaic cells that generate electricity, now we're going to get into more depth with the solar water heaters. So it says here we have many sunny days each year in South Africa. It says solar energy comes from the sun. We can use solar energy directly to heat up water in our homes, and solar water heaters use heat from the sun to heat water. So we have two parts here. You either have a solar heated geyser at home. Some of you may have that already and you know what I'm talking about, or you would have seen it when you drive past people's houses. You'll see that the geyser sits on top of the roof and it's got a panel that is facing the sun. So how does it work? This is the image that we have to take note of here. There's a few things that happen. So like the ones at the school, you would have seen all the solar panels on the roof. The pool pump will pump the water all the way up towards the solar panel, and as it gets to the solar panel one is a very dark color. It's black, so it can draw the sun. You want to trap as much heat as you can into the solar panel, so therefore you use the darkest color you can. And what the solar panel does is there's very small channels that run through it, so it slows the flow of water down. It makes the water flow slowly through the panel, and as it flows through the panel, it then starts to heat up. So I'm sure you've all experienced, sometimes you forget the hose pipe outside and it's sitting in the sun, and then when you switch the water on, you feel that it's extremely hot. Or you have pipes that are outside your house by a tap, and then the sun heats up those pipes, and then when you open up the tap, you can feel that the water is extremely warm. And it's the same principle. So it's pretty much the sun's energy heating up the water, but in order to heat the water up, we have to flow it down through the pipes. And as it slows down, then it heats up via the sun. Okay, so this is how a solar panel for water works. It's a total different setup to a photovoltaic cell. Once the water has been heated up, then obviously it returns back to the swimming pool, and then you'll feel usually the water pumping out by the pool's jets is warm compared to the rest of the pool, which is slightly colder because it's not as warm as the water that's coming through. Now, with the water entering the pool, then it will turn to a convectional current where it will start to heat the pool up, all right? And hopefully over a short period of time, not a short period of time, but over a few days or weeks, then the pool starts to increase in degrees that it's more comfortable to swim in. So what it says on the bottom of page number 124, it says cold water flows through the pipes of the solar heater, as we explained here. The sun heats the water in the black pipes and the solar heater on the roof. It says the heater has a glass cover to allow the sun's heat through. Our ones at school are just directly through the rubber. There is no glass through it. If there's a glass cover, please note that there will be a form of convection happening there. Okay, it says that the direction which gets the most sun of the day would be facing. So you want your solar panels always facing north in the southern hemisphere. You'll see that your houses also face north. It's just so they warm up very nice in winter. Anything that's south facing will be quite cold. So if you think about the classrooms at school, you'll know that Mr. Oliveira's class would be very warm because it is north facing, whereas the classrooms nearer the tuck shop, etc., will be a lot colder because they're more south facing, so they don't necessarily get sun during the day. The next one says here that the heated water flows to the hot water cylinder, which is connected at the water pipes in the house, and that's just pretty much a tank over here that stores the water. In this case, if it's a swimming pool, the pool itself acts as the storage tanker, because that's where you want the warm water to swim in. So now, using an insulating material, it says here that insulating materials slow down the heat losses and gains by conduction, convection, and radiation. People use insulating materials to reduce heat losses in winter and heat gains in summer. This is known as energy conservation. It says the best insulators are materials that contain air spaces. Is a very good example of very poor conductive heat, which makes a very good insulator. It says, for example, a thatched roof is a good insulator because air is trapped in the spaces between the pieces of grass and of the thatch. Because the air cannot move freely, all right, therefore the small spaces of heat transfer and convection is reduced as it cannot move up and down. So remember in that animation last week, you would have seen with the convectional currents, it prevents that from happening. There's other materials that also have large air spaces in them are good insulators. This will include wool, feathers, cork, grass, straw, styrofoam, and fiberglass. Okay, so let's put this into a more practical sense. Let me use this over here. So it says here, the more space you have, air space you have, the more it will insulate. And the reason why this happens, if you had the sun and this was a wall and the sun was radiating into the wall, it has to slow down the energy transfer. So therefore, as the heat starts to come in, it is slowed down. So it's a lot less, right? And then when it eventually enters into the room, it will keep this room cooler, okay? It also depends on what you have on top of your house. So as the roof, some of you may have that, it's called aerolite or think pink. So it's like a fiberglass fluff. If you think about it, it actually looks like candy floss, right? So it will be inside the roof. So as the sun's rays hit down against the roof, it dissipates and it slows down the energy transfer, keeping the room cool inside. Now this will be during summer, and then obviously in winter you're going to heat the room up, and it's the same thing vice versa. It's not going to allow the energy to radiate out of the room as easy as well. So that's all you have to think about when you think about insulating a house, is you want to create as much space as you possibly can, and then you can also add other insulators in between those spaces, being the aerolite or the think pink, which is a fiberglass material. If there's a video on YouTube, I'll link that for you, and then you can go and have a look at that as well to see what the insulating materials look like. And we've already covered the ones where you use plastic, etc., around handles of pots and so on, that you do not burn. Alright, grade 7. So there's a few things that you have to do this week in natural sciences. Let me just double check in the textbook here and tell you what activities you're going to be doing. Alright, so 1, practical activity. 2, you're going to see inside the video description. I've left a link of how this practical works. You don't physically have to do this, just take note of it, because you're going to answer the questions on the next page. Before you do that, please, you have to do activity 1 in your workbooks. That's just 3 quick questions explaining how the solar heater works, and I did go through it in detail with you. All right, and then on page number 126, once you've watched that video in the description about heat transfer and insulation, then I want you to answer the questions. So in this case, for the video, they explain it for you. If you want to, you can do your own measurements with your own thermometer. Other than that, you just have to say which one was better and which one was cooler, etc. Alright, grade 7s, that's it for the day. We will move on to using insulating materials on page number 126 and 27 soon. And then we're almost done with the terms work. You're going to have a small project to do for me. And we have about 4 more pages until we conduct the end of this term's work, and then we're moving on to term 4's work. And then at least that also gives us a cushion in NS for the bit of revision that we need just prior to you writing your final exams.